In this video, we're going to talk about position vector. So let's say you've got a vector v here, where the initial point is 2 across, 1 up. So it's 2 across, 1 up. And the terminal point is 5 across, 3 up. So it's 5 across, 3 up. But the vector itself is only 3 across and 2 up, 2 up. So we say two vectors are the same if the direction and magnitude are the same. So if you look at this vector here, let's call it u. We say that u is equal to v if the direction and magnitude are the same. So you can see that the direction here is the same as the direction here, because we would use gradients to determine direction. So the gradient here is 2 over 3. And the gradient down here is also 2 over 3. So the direction are the same. Now you could use angles to determine direction. You could use the angle theta, but then you've got to use inverse tan and things. It would be a lot more complicated to work out the angle to determine direction. You can just simply get the height divided by, you can just simply get whatever's here divided by whatever's here, rather than using inverse tan and things like that. Well, because the direction and the magnitude are the same, so we say that this vector here is equal to this vector here. If you look at this one here, even though the magnitude is the same, the direction, so normally it's 2 across, normally it's 3 across, 2 up. So even though the magnitude is the same, the direction here is different. So the gradient here will be different from the gradient here. So this vector is not equal to this one here. Now if you look at this one here, even though the gradient is the same, even though the gradient here is the same as this gradient over here, but then the magnitude is different. So this vector here is not the same as this. But this one here is equal to this. Now position vector. So this is your current vector. With position vector, well, position vectors, when you move the when you move the initial point to the origin, when it starts at the origin, then you have yourself a position vector. So any vector, let's say this vector here, this vector v here, is floating in the middle of nowhere. It's starting at whatever this location is, this location here. Well, when it's floating in the middle of nowhere, in your mind, move it so that it starts at the origin. Then you will have yourself a position vector. And the reason why we are interested in position vectors is that it will make life a lot easier to work. It would be a lot simpler to work with in the future. I will explain why in the next video. But if you have any vector, let's say if you have any vector, let's say this one here, in your mind, move it so that the initial point starts at the origin. And you can always move whatever vector you've got. You can always move it so that it starts at the origin. So this one here, you can always move it so it starts at the origin. And then this one here, bear with me. You can, no matter what vector you're given, you can always move it so it starts at the origin. So it starts at the origin. So no matter what vector you're given, you can always move it so that it starts at the origin. So when it starts at the origin, you've got yourself a position vector. Okay, so I will explain why position vectors are easy to work with in the next video. If you look at if you're working in 3D, you can always move it to the origin. So let's say you've got I will continue in the next video.